Okay, good afternoon, ladies and gentlemen. I will be presenting our latest work entitled An Analysis of Australian Political Discourse in Sponsored Social Media Content. My name is Lei Han, coming from the University of Queensland. It's a joint work with my colleagues from School of ITEE and Political Science and International Studies in UQ. So first, let me introduce some background of this work. This information is deliberately designed to spread false information over internet. It is not new, but recent evidence show that citizens are increasingly exposed to online disinformation. Although we don't know how much this may influence voting behavior, many stakeholders, including democratic theorists, policymakers, and commentators, have raised the concern that electoral campaigns can use disinformation to increase polarization, fragment the public, and increase dissatisfaction with democracy or major institutions as media and political parties and so on. Therefore, we aim at understanding how sponsored social media content is used in such political campaigns. We study Facebook political advertising. As the first step to perform such data-driven analysis, in this paper, we present our first work to create an Australian dataset that contains sponsored media content published on Facebook, as well as human annotations of that. This dataset can be downloaded through this link. It is here to enable follow-up research. This link also appears in our paper. So we continuously crowd sponsored advertisement posts on Facebook every 12 hours from February 2020 to May 2021. This is the released data set, but we don't stop. We continue doing this until now. And because we are close to the voting campaigns, so we crowd the data every 6 hours, more frequently to capture any change patterns, such as new ads coming in the morning or evening. We also have a plan to update the data set in the future. Now, I have to turn off this. It's here. Oh, okay. So now let me show you what the data set we have created looks like. We crawl the sponsored ads through Python code from Facebook API. Here is an example of the ad we have crawled. We extract the textual content of ads, such as the body text, like this, and the funding entity, and so on, paid by this funding entity. We also store the metadata of ads, for example, posting. Here, I just write it down. The metadata, posting data, demographic target, and money spent, and others, which are not shown in the original Facebook ad page. For the ads containing images or videos, we additionally download the multimedia file through Facebook API. For example, this advertisement, there is a video here. This is a video. This is a screenshot. So we also take the screenshot of the ad posting page. This allows us to publish crowdsourcing tasks, asking crowd workers to generate annotations. Having extracted the images and videos from these ad posts, we use Google Cloud Vision API and Video Intelligence API to create labels describing the image or video. These labels include general objects, locations, activities, animals, and so on. Overall, we crowd 35,000 distinct posts from Facebook. 70% of these were posted with images and 20% come with videos. And a few ads come without images or videos. In terms of the created labels, we have 2,200 labels for images and 1,200 for videos. Because Google Cloud API also provide a confidence score for each generated label. We also plot the distribution of the confidence for each predicted labels. Here shows the average confidence for each created label. Because different images may give the same labels, so we take the average. We can see that the confidence score for image labels is higher than video labels on average. We also see that 80% of the videos are short, 2 minutes or less. When we download these videos, long videos have a higher chance to fail. For example, here, the green dots are the videos that failed. They are actually longer. In this table, we show the top 10 most frequent labels. We can see that the most videos are related to speech, speaking, and presentation. By contrast, in images have a diversity across different ads, such as font, event, and plant. To generate annotations for this ad post, we run a crowdsourcing task, labeling task via a mechanical Turk in two-stage manner. This screenshot is our first stage task. At the first stage, we present the snapshot of the ad that we captured from Facebook. And we ask crowd workers to label 2 types of information. These 2 questions. First, if the given ad is an election ad or not. And second, if there exists a subject, either a person or organization that this ad refers to. They can go to Google to search for relevant information. So we get the binary labels for these 2 questions. For each ad that are both election ad and having a subject, we create a long task for more detailed annotations. This is stage 2. This stage 2 is not shown in this paper when it was published, but we have provided a screenshot of the task alongside with our published data set on GitHub. I will also talk about this task later in today's talk. In the short task, each worker labels 10 ads. 2 of them are gold questions. We have already collected the labels from experts. They are doctoral candidates in political science in UQ. So there are 2 binary labels for each ad. 2 ads are gold questions. That means that we have 4 labels as gold standard here. 2 labels per ad, 2 ads are gold questions. So this allows us to check their quality. We also send the same ad to 3 different workers so that we can check inter-annotator agreement for each label. To sample from 34,000 ads for our labeling task, we consider that the number of newly posted ads may vary from one day to another. So we sample this ad by the frequency of new ads on a daily basis. Here we can see how many new Australian sponsored ads appearing on Facebook over time. So we randomly sample from these ads on a daily basis, and we keep 2 ratios in our samples here. We keep the 2 ratios. The percentage of the ads posted on a specific date to the number of ads in our database, and the ratio of ads with images to those with videos. From this distribution of new ads over time, we can see that the posted ads either with images or videos are significantly more in September and October in 2020 in around this period compared to other months. One explanation could be that Queensland election was held on October 31st, 2020, so the numbers may reflect that around this date. So with this sampling strategy, we select 2,440 ads for our labeling task. As a quality control strategy, we embed a time-based check in the task, requiring workers to spend a certain amount of time on each ad. We also check their answers to the GOAT questions if they are the same as experts. Remember that we have 2 ads serving as GOAT questions, and we have 2 questions for each ad. Election or not here. So there are 4 labels that we can compare with experts. For those passing these conditions, in addition to that, we require the answers to the same ad, the same across all qualified annotators. That means that for a specific ad, all annotators provide exactly the same answer. This can be regarded as a complete agreement among annotators. So in this table, we show the number of ads that are provided by those who pass all the quality control conditions. We can see that if we ask workers correctly give all the 4 GOAT labels, that is here, all the 4 labels are correct, we can only get 800 ads being labeled. So in our work, we allow them to make mistakes in 1 label. That is requiring each worker to provide at least 3 out of 4 correct labels for GOAT questions. This gave us 1,400 as being labeled. Oh, wait. This is up to when the paper was published. So after the paper was published, we conduct another round of these short tasks. So this number, 1,400, now becomes 3,000 now. We also publish these labels on GitHub as part of our dataset. Remember that for these ads, all workers who passed the quality check have given the same binary labels. So we consider these labels are in good quality. Using these obtained annotations, we select the ads, which are both election ads and having a subject that is the first row. To create our second stage task, that is a long task for detailed annotations. In our paper, we explain our plan to design and implement the second stage long task. Now we have collected the detailed annotations from mTurk. Here is our long task. Each task has 3 pages. Now this is the first page, where we ask them to label which party or non-party organizations or posting entity is 2 questions, and which Australian state and or area posting entities from is these 2 questions. Because this is a long task, we only require labeling 1 ad per task. To find good quality workers, we invite those who participate in our short task and have passed our quality checks to attempt the long task. We use 2 ads that are already being labeled by our experts and send them to qualified workers. After collecting their annotations, we perform 2 quality checks. Here is the quality checks. So 1 is the GOAT question. This is the same as what they did before, because but they have never seen these ads. If they click on no, that is this question. If they click on no, all the following questions will disappear. So it becomes much easier for them to get the monetary reward. But we know the answer, it should be yes, based on the result from our short task. So this is the first quality check question. The second quality check is by attention check questions. In question one, we ask which party of the posting entity is from. In question 2, we ask which non-party organization of the posting entity is from. If they select any party in Q1, they should select parties and actors in Q2. That is this option. If they select any non-party organizations in Q2, they should select a non-party as the answer to Q1. So if they select a party in Q1 and a non-party in and a non-party actors in Q2, it doesn't make sense. So in this way, we can filter the workers and select good quality workers that we call super worker. And we invite all super workers to do our tasks. Each of them, we send 50 tasks and we pay 60 cents. Here, we pay 60 cents per task. And we also check by this strategy when they finish all the tasks. If they pass our quality checks in 40 out of 50 tasks, that is 80%, we reward them another $15 bonus. This is the task page 2. All questions about the subject. We have gold questions here, gold questions. We have attention check questions here, these two. We ask them who is the subject is. Here, Q4 is who is the subject, which area they come from, 7. And we also ask them the attitude or sentiment towards the subject of the ad. We also require them to provide an explanation of the sentiment score they have provided here. That's a justification. Here is task page 3, where we ask the topic of the ads and truthfulness evaluation of the ads. Topics and truthfulness evaluation. We believe that these created annotations of the truthfulness and various political aspects for a sample of sponsored ads posted in our collection allow to train supervised machine learning models and to classify, and then to classify the entire data set, that is 35,000. As well as for further analysis, for example, the use of disinformation on social media. So here I show you some of our example analysis from our data collections. This is the total money spent by each party with a breakdown of the sentiment and terms appearing in the ad posts. We can see some differences between different parties. For example, Greens talks about more on climate, but Labor talks more about health, and Liberal talks more about jobs. So they have different focus. This is another example, parties talking about parties. We can see that the Greens always talk about themselves. Well, Labor doesn't like talking about parties, so they have less money spent on these things. In March 2021, here, this month, we see Greens talk a lot about themselves. Then Liberal talk about labors. So we can get some insights from such data for future research. All these are mined from the textual body of the ads posts, which we included in our published data set. This is the money spent by Labor and Liberal in different states with a breakdown by different topics here. This is another example of analysis we can make from the published data set. We also built a dashboard showing some statistics from various perspectives. This can allow us to get some idea on time while the political campaigns are going on. The numbers and graphs showing here are real time, but it's just a snapshot. When it's online, we will publish the URL so that everyone can see that. So in conclusion, online disinformation has been shown to be influential in deliberately spread misleading information. To understand how disinformation can affect voting behavior, we studied the usage of sponsored social media content in political campaigns. In this work, we create a multimodal dataset including 35,000 sponsored Australian ad posts crowd from Facebook. Although a crowdsourcing task, through a crowdsourcing task deployed on Amazon Mechanical Turk, we collected binary annotations for 3,000 ads, where we asked whether a given ad is an election ad post, and if the ad has a subject. Based on these collections, we run a second stage long task to collect more detailed annotations on various political related information, as well as the truthfulness evaluation of the ads. This paper is now our first work towards understanding how this information has led to the formation and parliamentary committees in many advanced democracies in Australia. To enable follow-up research, we published our data set and the task design. So this link is online now. Our future work will extend from this paper using these annotations to train machine learning models to classify all ads posts in our dataset, as well as performing detailed analysis from various political perspectives. Okay, that's all my presentation. Thank you for your attention. Thank you.
Thank you.